Alright, this section is sort of important. I guess not that they all aren't important, but we're talking about disjunction. Alright, disjunction means when we're looking at two sets, and we're going to talk about it because, again, it kind of makes sense to revert back to the Venn diagram cases. So I have event A and event B, and I want to know what's the chance that event A or event B will happen. Alright, so either A happens or B happens, or they could both happen, and that would be all a part of the same probability. The biggest thing with the or statement is we have to use this formula so that you don't count anybody twice. And where the formula kind of comes from is if you sort of revert back to the Venn diagram. So I'm going to draw a Venn diagram over here. The Venn diagram would represent 100% of the probabilities, or again, it's equal to 1, the probability of 1. We'd have A that is inside, B that is inside. And so A, the circle A would represent all of the ways A can happen. Circle B would represent all of the ways B happens. And there's this overlap. And that's what the AND statement is, right? That's the probability of A and B. And so when I add up the probability of A and the probability of B, I counted that over what we call the overlap twice. And so I have to make sure I subtract one of them. And the easiest way to see that is in an example. All right? You kind of have to look at an example. Again, the biggest thing with anything is we never want to count anybody twice. And we never want to make people twice as likely. If they land in both circles, and I counted them in A and I counted them again in B, I'm counting them as two people instead of one person. And so I'm making them twice as likely as they really are. And again, so the probability would be wrong. Alright, so an example. Suppose that we know that the probability of student enrollment in an English class is 0.75. So 75% of the students enroll in an English class. The probability they enroll in a Spanish class is 0.35. 35% of the students enroll in a Spanish class. The probability they enrolled in both, meaning there's 20% of students, out of all the students, 100% of students, enroll in both. They're counted in the English group and the Spanish group. And so I've got to make sure those 20% who are in both aren't counted twice, otherwise it's no longer equally likely. Alright, so I want to know the probability that they're in an English class or a Spanish class. And so it's the probability they're in an English class plus the probability they're in a Spanish class minus the probability they're in both an English and a Spanish. And I have to subtract, because if I don't subtract, I'm going to count the people who are in both 2 times, and so I'm making them like they're 2 people, like they're themselves and the doppelganger, and I don't want to do that. And sort of make sure, I'm going to plug it in, and then I'm going to double check with a Venn diagram. Alright, so if I plug this in, probability of probability of English class, 75, probability of Spanish class, 35. The check that I need to subtract is when I take the probability they're in an English class, add it to the probability they're in a Spanish class, that comes out to 1.1, which, if you recall, probabilities cannot be greater than 1. This would represent 110%. You can't be 110%. And so that reminds me, well, there must have been some overlap that I need to subtract. There must have been people that we counted twice in both sets. And there were people who were in both sets. And so when I subtract away the 0.2, the 20% who were in both, it comes out to 0.9 or 90% that were in English or a Spanish class. And sort of kind of check that out with the Venn diagram. I'm going to get myself a little more room over here. Alright, so I'm going to write my 0.9, which again represents my 90% of those in a Spanish or an English class. Alright, so to sort of put that in terms of a picture, alright, so this would represent 100% of the students. Alright, I'm going to write them as percents, because I think it's just easier to deal with percent. These would represent, of the 100% of the students, those are all the people in an English class. This represents all of those in a Spanish class. So the English circle should add up to 75% of the students. In the overlap, which would be the probability they're in English class and a Spanish class, well, that was 20%. So 20% out of all of the students are in both, which means there are only 80% left. And so now if I look at the circle English circle should add up to 75%, 70.75. So 75% of them are enrolled in an English class. I've already counted 20% who are also enrolled in Spanish, which leaves 55% who are in an English class but not a Spanish class. English circle, adds up to 75%. Do the same thing with the Spanish. The Spanish circle should add up to 35%. We've already counted 20% of them that are in an English class, which leaves 15% that are in a Spanish class and not an English class. If you add these up, this does add up to the 90%, which means there's technically 10% out here that didn't land in either, right? 10% didn't have an English class, so that'd be the not in an English class, and not in a Spanish class. All right, so again, make sure you're careful with the overlap. Now, I'm going to do my next example is going to be an example where there is no overlap. All right, but you'd always check for overlap. We never want to count anybody more than once. All right, so my next example is find the probability that if you randomly select a card from a standard deck, so we want to, pop up my standard deck of cards. What's the probability of the deck that I draw? Probability of randomly select a card from a standard deck is a king or a queen. So probability I draw a king or a queen. So K represents king, so probability king plus probability of queen. And then if I write my minus, because it doesn't always hurt to do that, you're always safe if you write the minus. This would begin any overlap. Well, if I go look at my deck of cards, right, these would be over here, would be all of the queens and the kings. You'll notice there are 4 queens and 4 kings. You cannot be a king and a queen at the same time. If I draw a card, it is either a queen or a king. You can't be both. And so in this case, this comes out 0 because it's what we call disjoint. You can't have a card that is both a king and a queen at the same time. So in this case, you don't have to worry about the overlap. The overlap doesn't matter because this is 0. This is none. Alright, so I'm actually going to erase it. And so I only have to add up the 2 probabilities. So as long as there's no overlap, I don't have to subtract. But if there is an overlap, and I should always check to see if there is, I then need to make sure that I subtract anybody I counted twice. Alright, so this one's just probability of a king. Well, there are 4 kings out of 52. Probability that there's a queen. There's 4 queens out of 52, which means there are 8 possible cards. And you could have gone straight to the 8, right? There are 8 altogether, right? 4 kings, 4 queens, so 8 possibilities if I'm picking a king or a queen. So 8 out of 52, then you write that as a decimal or fraction. The fraction simplifies to 2 out of 13, or the decimal is 0.154 if I round 3 to decimal, or 15.4%. Alright, the last one of this example, now I'll stop this video here. Find the probability of random select card from a standard deck is a 10 or a red. So this one's different. You want the 10 or a red card. So this would be the probability it's a 10 plus the probability it's red minus the probability it's a 10 and a red. This time there'll be overlap. So remember, when you're looking at this sheet, those are the red cards. The hearts are the red cards and the diamond are the red card. 26, half of the deck is red, half of the deck is black, and we want the 10s, so we've got 10s here. And so there is overlap. I have 2 of them that are red and a 10 at the same time. So this time I do have to subtract. All right, so go back to my probability. So the probability I get a 10, well, there were 4 10s out of 52. Red cards, that's half the deck, so 26 out of 52. I did count 2 10s in the reds, so I have to subtract 2 out of 52 because I counted those 2 twice, right? If I count all of the red cards, all of the red ones, all the diamonds, all the hearts, and all of the 10s, these 2 get counted twice. Means if I don't subtract, I'm counting the deck as having 2 10 of hearts and 2 diamond of hearts, and I don't want to do that. Alright, so you have to make sure that you don't count anybody twice. Alright, then you just, excuse me, finish that up. So this simplifies to 28 out of 52. That's the fraction. You either write that as the simplified fraction or the decimal. It simplifies to 7 out of 13. Or the decimal, which is 0.538 or 53.8%. Alright, I'm going to stop there. I'm going to pick up the next set of notes, which is empirical probability, in the next video.